Hello everyone. I'm going to add one more linear equation video for intermediate algebra people. The problems that are in our intermediate algebra go a little bit beyond where the linear equations are in Math 100. And so therefore I'm making another video for you guys because I think you need it. So what are we looking at? When we move into intermediate algebra, the problems get longer and longer and longer. And as they get longer, what happens? Now you have a lot more steps. You use distributive property, you use simplification by combining like terms, and then you end up with an equation that will get to the place where you already know from Math 100. So let's look at what can happen with these equations as we move into more and more complex equations. So let's look at this one that I have here. Okay, as you can tell, that's quite a bit longer than the ones that we have done before. First of all, let's look at this and analyze it a little bit. Here we have a term with a variable. Here we have a parentheses with a number outside. This is going to require a distributive property before we can do anything else. This one over here is the same. It is also going to require the distributive property. So let's look at this. We have 5x plus, you're going to go 8 times x for 8x, and then 8 times negative 6, which is a minus 48. And this is equal to 5 times x, which is 5x, and then 5 times negative 8, which is minus 40. Now, looking at this side, we have two like terms, 5x and 8x. So you're going to have to add these and get 13x minus 48 because there's nothing to add to it, and 5x minus 40. Now you're ready to move all your variables to one side and your numbers to the other side. So I have a 5x and a 13x, so I'm going to subtract 5x from both sides because this is a positive, so to turn that into 0, it has to be negative. This is going to leave us with 13 minus 5, which is 8x, minus 48 is equal to negative 40. Minus 48, so you do the opposite, which is your add 48. And this becomes 0. 8x plus a 0 is simply 8x is equal to negative 40 plus 48 is an 8. Divide by 8, and we end up with x is equal to 1. So as you see, your final number is actually very simple. It's the number 1. But there's a lot more steps in the process to get to the final answer than what we had in Math 100. Okay, now let's look at another one that we have here. I'm going to do one that uses more grouping symbols. Let's look at this one. I have 8 and then a bracket, 2 minus, in parentheses, 3 plus 6x, and close my bracket, minus 2x is equal to a negative 10 plus 2 times 1 minus 25x. Hope we can see that at the top. Yes, we can. Okay? So, what's going on with this one? Well, let's look at it first. Remember, from your order of operations, you're going to start with what's inside. So here we have inside this parentheses, that's inside the bracket. This is a negative. So this is the same thing as saying a negative 1. So we've got a negative 1 times 3 and a negative 1 times 6x. So let's write down everything else. Negative 1 times 3 is a minus 3. And negative 1 times 6x is a minus 6x. Your parentheses are gone because you've done what it required to do, but we still have our bracket. Minus 2x is equal to negative 10. Let's go ahead and do this parentheses too. 2 times 1 is a plus 2. A 2 times a negative 25x is a negative 50x. Okay, we can simplify inside this bracket. 2 minus 3 is going to be a negative 1 minus 6x. And don't forget, outside the bracket, we still have that 8, which multiplies that. Minus 2x is equal to negative 10 plus 2 is a negative 8 minus 50x. Now notice, my right side is completely simplified, but the left side of this equation still has to be simplified with using the distributive property. Since this is multiplication, these are not like terms, so they cannot be combined. So 8 times a negative 1 is a negative 8, and 8 times a negative 6 is a minus 48x. Minus 2x equals negative 8 minus 50x. Okay, we still have two like terms to combine on the left side. So you have negative 8, negative 48x minus 2x is a minus 50x, is equal to a negative 8 minus 50x. What do you see here? You see that this side is exactly the same as the other side. So if we decide to go from here, what's going to happen? Well, if we add 50x to both sides, this is going to produce 0 in both cases. And you are left with a negative 8 is equal to a negative 8. And if you remember from the previous video, this is a true statement because negative 8 is equal to itself. Therefore, this is a true statement. And a true statement indicates that all real numbers is your solution. That means all the real numbers out there will make this a true statement. So your solution has many, 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 many solutions. Everything is possible. Now, those all real numbers, this also has a name. And the name of this problem is called an identity because it identifies itself. So this is an identity, and it's all real numbers is your solution. Because we end up with a true statement here, or it could be 0 equals 0, because if I added 8 to both sides, I would end up with 0. Okay, let's move on to another problem. Okay, let's look at this one. It's got fractions in it. 6/7 times x minus 5/6 times x is equal to 11/12 times x minus 13. Okay. So what we've got going here is fractions. And what we're going to have to do, we're going to have to deal with these fractions by finding a common denominator. And to find that common denominator, 7 and 6, well, that would be 42, but 12 doesn't go into 42. So we're going to look for something that 7, 6, and 12 goes into. Well, if you look at your multiples of 12, and you go, you're going to find that 84, which is 7 times 12, is your lowest common denominator. So we're going to change all of these into a denominator with 84. And notice, as I do this, I don't put my x in the denominator because the x is what's being multiplied here, 84x. And then this one, we're going to leave it as minus 13. So, 7 goes into 84 12 times, so we're going to multiply it by 12. Do the same to the numerator, so 6 times 12 will be 72. And 6 times what is 84? Well, 1 and 24, that will be 4. So 6 times 14, so 5 times 14 will be 20, carry my 2, 5, 70. 5 times 14 is 70. 12 times 7, so 11 times 7, making 77 over 84x times x. Okay, now we can combine our like terms. 72 84x minus 70 over 84x is 72 minus 70 will be 2 over 84x is equal to 77 over 84 times x minus 13. We are now going to subtract that 77 84x from both sides. So I'm going to do minus 77 84x here. That becomes a 0, and 2 minus 77 is a negative 75 over 84x is equal to a negative 13. Now, our next step will be to eliminate this fraction. We can do it by either multiplying by the reciprocal or doing 2 steps. Let's try the reciprocal here. Let's do this times negative 84 over 75, and do the same over here, negative 84 over 75. So what's going to happen here? Well, this is going to be a 1, negative 84, 84, negative 75, and 75 gives you 1x or x, and it's going to equal what? Well, let's see. I think 13 goes into 75. How about, I don't know, let's try. 75 divided by 13. How about 6 times? No, can't be. Has to. How about 5? 5 times 13 is 15. Carry my 1, 5, 6. That's 65. Nope, it's not going to go in evenly. No such luck. So we're going to have to multiply 13 times 84. I'm going to grab a calculator to get that done quick. 13 times 84 is going to give you 1,092, and it will be positive over 75. And I don't believe that may simplify, but I doubt it. Yeah, it does. You can divide 5 by 75, 364, 364 over 25. In other words, it's divisible by 3. And that's going to give you 364 over 25 is what your x is equal to. So this is not such a pretty problem. It's got a lot more complexity to it. And the key is finding that common denominator, and then the rest of it is just like you've been doing, but because you've got fractions, it makes it a much more difficult problem for most students to do. And so that's the last one that I will do. But I just wanted to do these more complex problems to show you that as you move up into the higher level of math, your problems do become more and more complex, but the principles are the same. As you see, what happened here? We got the common denominator, and then we combined our like terms, just like we've been doing. We eliminated so that we had only one side with the variable. So you subtracted your 77/84x, leaving you with a 75, negative 75/84x. And again, now eliminating that fraction by doing a reciprocal. We could have multiplied by 84, then divided by 75, but we did this reciprocal, which in essence gave us the same process. Had to multiply negative 13 times negative 84, making a positive 1,092, and then simplified our fraction and left it in fraction format, because that is usually what will happen on these, because a fraction is an exact value, a decimal is an approximation. So that is the last problem I'm going to do for this particular video. Good luck on all your problems. Have a great time.